All right, now that we've introduced all the basic identities, I need to show you how to use them to try to simplify or manipulate or prove something. So right here we have tangent squared of t multiplying a cosine squared of t plus a cosine squared of t. Uh, your objective for this problem is to try to simplify it. And there are lots of different ways to do this. So there's no one set method. It's all about the vision that you have. And my job goal is to try to help you create a vision. All right. So let me tell you I would what I would say before you pause this video. Take a look at the fact that you have a lot of squared um, trig functions and think about what you could use to help you with these squared trig functions. And if you pause right here, take a minute to try to work it out for yourself, that would benefit you. Um, and then I'll show you a couple ways you can do this. Okay, so here we go. The first thing I notice is I see tangent, tangent and cosine, right? So I don't see a reason to use the cofunction identities because typically when you use the cofunction identities, you would want to see like the pi over 2 minus theta as the input, and I don't see that there. So I can say this shouldn't apply. Um, Same with the even odds. I don't see any minus signs in here, so I don't see how the even odd identities can help me out. Uh, I don't really see any of the reciprocals in here right now, so I could say we. I don't see how this one works, but maybe you do, and that'll help you out. So I would say definitely we want to start with these Pythagorean identities because of these squares that I see, right? The issue is that the tangent and cosine aren't in the same identity. So we could do this a couple ways. We could rewrite tangent in terms of a sine and a cosine and then try to simplify that. So if we do, I can replace this tangent squared of t with a sine squared of t divided by a cosine squared of t, which is then immediately multiplied by a cosine squared of t. Then you add a cosine squared of t to that amount, right? And from here, you can notice that if I do this multiplication, well, these two will cancel out. So I really just end up with sine squared of t plus the cosine squared of t, right? And I know that sine squared of t plus cosine squared of t should equal 1. So as a result, I can say my final answer should be 1. So I can say this should equal 1. And that's all you do with these identities. It's start somewhere, develop some sort of vision based off what you see, try it out, and hope that it works out. And don't this is where it's okay to go to try something and realize I don't think this is going to work out and then have to double back. Happens to everyone the first time through when they work with these trig identities. All right, cool. So that's one way you could do this, but there's another way depending on what you saw, right? If you didn't see that, we could have done this instead. Because you could have also noticed that the expression in the black at the very beginning, they both have cosine squareds. So what you could have done is a little bit of factoring, right? You could also alternatively see this as a cosine squared of t times tangent squared of t plus 1, right? Because if you see it this way, then here's what happens. Well, I know that 1 plus tangent squared should equal a secant squared. Since we're still adding a tangent squared and a 1, that's still going to produce the same secant squared. So this problem, you can think about it as a cosine squared multiplying a secant squared. Okay, and now that I have secant, I think about using the reciprocal identities. So secant is the same as 1 over cosine. Or if you wanted to, you could also opt for writing cosine as 1 over secant. I personally like to keep things in terms of sine and cosine, so I'm going to go with replacing the secant. But you're not wrong if you replace the cosine instead. I won't do both, though. So I can think about this as cosine squared of t multiplying a 1 over cosine squared of t. Okay? And if I do it this way, then here's what happens. Cosine squared of t cancels out with cosine squared of t, so you end up with 1 times 1, which gets you 1. Double verification. You don't have to do it both ways. I'm just trying to show you that for these identities, there's more than one way to solve them, and it all depends on what you see first and what you want to use. All right? So for the assignment, I'm going to give you a couple of these identities and ask you to manipulate them to simplify them. And your job is to somehow take all the information here and apply it to simplify it. Sometimes you get just a number, sometimes you get an expression, and that's fine, right? So good luck. Hope it helps. Stop by office hours if it doesn't.